Okay, we're getting down there, guys. I think there'll be one more section after this, but this is lesson 4.5, the number of solutions for a system of equations. Okay, could have one solution, zero solutions, or actually infinite. So it's just showing that you know how to determine how many solutions there are. We'll do 3 examples here. Okay, first example, negative 3x plus y equals 1, and negative 3x plus 2y equals 5. We're just solving this like normal, either elimination or substitution. For me, elimination looks like the way to go here, because if I just minus these equations, I would actually get, I'm going to rewrite them here. I could get the x's to cancel out. Okay, so rewrite the top one. This one I'm just going to distribute that negative in. So I've got 3x minus 2y equals negative 5. Make sure you distribute it to all parts there. Because now if I put these together, basically add them, negative 3x plus 3x is 0x, 1y minus 2y, negative 1y, and 1 minus 5, negative 4. And I'm not even going to continue solving this because, hey, I know if I get a y, I can find x, and there will be one solution, like x, y I'm talking, okay? There'll be one answer. If you think about graphically, if I graph these 2 lines, they basically cross at one single point. Okay, there's one x and y that works. Okay, let's do some that have 0 solutions or infinite. Let's see how this one works out. To cancel on this one, I've got 3x plus 4y equals negative 4, 15x plus 20y equals negative 22. I'm going to just times this top equation by negative 5 because I see that will cancel out the x's, because I'll have negative 15x and 15x. Okay, rewrite them, distribute it to all of them, equals 20, and then this bottom one I'll just keep the same. Okay, look what happens here. 0x, 0y, right? 20y, negative 20y plus 20y, just 0. So all together, all we have is over here is 0. And then 20 minus 22 is negative 2. This is never true, okay? When is 0 ever equal negative 2? It's never true. So if you get 2 numbers basically that are not equal, or 0 equals something, this is never true. So there's no solutions. If you would, no solutions, that's the answer, 0 solutions. If you would graph these, they would wind up being parallel lines. Okay, in other words, they never would cross. You would never get an XY solution. So this does not mean x is 0 or x is negative 2 or anything like that. It just means, hey, there's no answers to this. They never cross. Okay, and then the last scenario would be this one. Negative 6x plus 5y equals 7, and 30x minus 25y equals negative 35. Looking at that, I'm just going to multiply by 5, I guess, because I can see if I multiply by 5 up here, I can get the x's to cancel. Negative 30 plus 30. Let's rewrite that. Plus 25y equals 35. And then I got 30x minus 25y equals negative 35. Combine those together, add them. So negative 30x plus 30x, 0. 25y minus 25y, 0. And then 35 minus 35, 0. So I get down to 0 equals 0. Okay, that's always true, right? I mean, 0 equals 0 is always true, as opposed to 0 equals negative 2 is never true. Okay, this is always true. So if you get down to something like 0 equals 0, or something like 2 equals 2 or something, but I think it's normally just going to be 0 equals 0. It's always true. There's infinite solutions, you're going to say. Okay. What's that mean graphically? It'd mean, well, these 2 lines are actually the exact same line. Even though they didn't look like it originally, once I kind of multiplied this by 5, you could see they're really the same line. If I would multiply this one by negative 1, it would be the same line as this one. So if I would graph these, it's a little weird, but if you would graph these out, solve them for y and graph them, they actually would be the exact same equation, even though they do look like negatives of each other. Okay, so that's the three scenarios. If you get 0 equals 0 or some number equals some number, the same number on each side, infinite solutions. If you get some two numbers that don't equal each other on either side, no x's, right? Just two numbers that don't equal each other, no solutions. But if I get down to x or y still remaining and a number, even if that equals 0, even if you get y equals 0, that came up on some of your previous problems, that still means that there's an answer. You got one solution. Okay, that's pretty much what you need to know for today, guys. Have a good day.